Namaste to all paramedical students, especially dialysis students. Today we are going to know about our RO plant. What is RO plant and what is the function of RO plant? How does it purify our waters for the dialysis treatment? Basically, we know that RO water is needed for hemodialysis. Generally, the ratio of dialysate is 1:1.83:34. In that ratio, part A is 1, part B is 1.83 and RO water is 34. So if we take 1 liter of part A, then we have to take 1.83 liter of part B and 34 liter of RO water to make a dialysate for our dialysis treatment. So in this picture we can see a RO plant diagram. RO plant is made of various filters, pumps and membrane. So we are going to know that. The first one is a tank which stores the raw water. Then from this tank water came to a temperature binding valve. From that temperature binding valve water comes to a booster pump which forces water to pass through these filters to RO membrane. There are a lot of filters, 1, 2, 3, 4, and we have to know all of those filters. So we start our class on RO plant. So there are three parts of our RO plant in dialysis unit. The first one is pre-treatment, second one is primary purification process, and third one is distribution of purified water. Pre-treatment means where the larger molecules are purified. Second, primary purification process means where the smaller solutes and bacteria or endotoxins are processed. And third one is distribution into our dialysis unit. Pre-treatment system are made of 7 parts. First one is temperature binding valve. Second one, backflow prevention device. Third one, booster pump. Fourth one, multimedia filter or sediment filter. Fifth, water softener. Sixth, carbon tanks. Seventh, cartridge filter. So it might look like a long system, but it is very easy if we know the mechanism. Now here is another diagram where we can see that a cold water and hot water mixes in the temperature binding valve. Then it passes through a backflow prevention device. Then it comes into a booster pump. After that it passes through a multimedia filter, also called sediment filter. Then water softener. Then primary carbon tank means the first one. Then secondary carbon tank means the second one or polymer. And then it passes through cartridge filter. After that it goes to our second part of RO system is RO membrane, where small molecules are purified. Here is a photo of temperature binding valve. After that temperature bending valve, water passes to a filter called booster pump and flows away. So what are the function of that booster pump? So we use the booster pump, but what is the function of that booster pump? The main function is stable RO operations. Means sometime water pressure can be much more than we needed and sometime it going to be low. So a booster pump maintain a stable RO water pressure to maintain a stable operation. Adequate backwash and regeneration cycles. When we regenerate our filters and backwash our tanks, then at that time adequate pressure is needed, which is provided by the booster pump. Eliminate wide pressure, which I told before, to maintain a constant continuous pressure. How we can going to monitor those pressure? By a pressure gauges. Here is the photo of a booster pump. We all know that type of booster pump in our RO plant. So comment me below who already see that type of booster pump in our RO plant. Then water goes to depth bed filter or multimedia filter or sediment filter. Multimedia filter or depth bed filter is primarily made of earth materials like sands, granites, etc. So water passes through large molecules, then the small ones and the small molecules are trapped in that sand. After that the pure water is go back to top and process to our second tank. Here are the principles of multimedia filter. Particle removed to 10 micron, backwashable, means the first one is we can remove the particles which size is large more than 10 microns. Then it can be reused by backwash. It can be largely capacity, means a huge amount of water can be purified. Monitoring, we can monitor it, pressure gauges and time settings, means we have to backwash and restart that process. Here is the photo of a multimedia filter. So water passes through booster pump, come into that filter, more than 10 micron size are trapped in that filter and other small molecules and water, purified water, passes through tank to our second filter. So our second filter is water softener. Water softeners are the filter which decrease the hardness of water by removing calcium and magnesium mainly and other solutes also. So water pass through this and also from that side water passes and filtered water passes to our third filter. The water when passes through this, there are resin beds which have ions. In this picture we can see that magnesium and calcium are trapped in the resin bed and water is free from the calcium and magnesium and the hardness of water is decreased. Here are the mechanism of water softener. Ion exchange process, remove calcium and magnesium, the hardness ion and soft sodium ions add করা হয়. Monitoring, hardness test, timer settings, bearing tank salt level. We can see that a water softener in our real life. So there are another tank which is called regeneration tank. So we use sodium chloride for regeneration of our resin bed in water softener. Water softener exists every time of use and then we used a regeneration process where sodium chloride is passes through that membrane resin beds, and then sodium is trapped in the resin and make it like a new one. And after the regeneration process, we again can purify our water to become softer water by removing calcium and magnesium from the water in that water softener. The third tank of our RO system is carbon filters. Here we can see that carbon means GAC, granular activated charcoal, in that tank. So water when passes through that charcoal, then the chloramine and chlorine is trapped in that charcoal and the purified water passes from that tank. So we see that two carbon tanks in our RO diagram, RO plant diagram. So anyone can tell me that the name of those two tanks? Please comment below. Carbon filter media, granular activated carbon, iodine number more than 900. There are two carbon tanks. The first one called is primary, second was secondary. Means the first carbon tank is worker and then second is polisher. Water passes to first one, then comes to second one, then towards the cartridge filter. Here are the photo of carbon tanks. If carbon tanks exhausted, then we have to put a new one. The fourth section of our first part is cartridge filter. Here is the photo of cartridge filter, which generally filters our water from 5 micron or larger molecules. So water passes from the inlet and passes out through the outlet for the RO membrane. Mechanism of cartridge filter: particle removal to 5 micron or smaller, pre-RO installation, occur cartridge housing mandatory, remove particles of 5 micron or smaller, monitoring by inlet pressure gauge. So again we are going to remember our pre-treatment system, which is a temperature binding valve, then water passes through backflow prevention device, then to a booster pump, then we can see the first one is multimedia filter, sand filter or depth bed filter, then water passes to a water softener which is regenerated by NaCl solution, then water comes to our first carbon filter which is called primary carbon filter, which removes chlorine and chloramine. Water softener removes calcium and magnesium, which causes hardness. So multimedia filter removes the particles which size is more than 10 micron. Means the molecules which size is more than 10 micron is removed by the multimedia filter. Then the hardness causing molecules magnesium and calcium are removed in water softener. After that, chlorine and chloramine is removed in carbon tank, basically the primary carbon tank. Then the purified water passes to our secondary carbon tank, which act as a polisher. After that, water passes to a cartridge filter. Cartridge filter removes the molecules size 5 micron or smaller, because now the water is going to pass through the RO membrane. Now after the pre-treatment system, we are going to purification and distribution system. The second part of our RO plant is purification. Purification process, we are going to remove the inorganics, bacteria, endotoxins, and we are going to monitor by monitors and gauges, lab testing chemical, bacteria and endotoxin level. Purification of water is done by basically reverse osmosis membrane, and sometimes we use deionizer and ultrafiltration system. So in that diagram we can see the water from pre-treatment system is passes to a pump which flows the water to our membranes, and here the purified water are passes to our storage tank. from that area the water which is rejected we are going to throw it. Here is a photo of our RO system, RO membrane. Here are the membranes, and now in the larger RO plant we can see a larger membranes. Basic function of our reverse osmosis system: pump and membrane system. Second is removes chemicals, bacteria and endotoxins, monitoring inline conductivity monitor. Second is inline flow and pressure gauges, and we have to lab test chemical, bacteria and endotoxins. Or now we also have to maintain TDS, total dissolving solids. Deionizer. So what is an deionizer? Deionizer also a filter which exchange ions with cations and anions. So if it exhausted, then it can be dangerous. So we have to monitor the post filter water and lab testing of chemicals. Here deionizer works ion exchange process. So here is the cations and here are the anions. So positive charged are put in that place and a hydrogen ion put into water, and same process a anion put in to that anion resin and a OH put to our water. Those mixes and make pure water. If deionizer exhausted, then it can create hydrofluoric acid which is dangerous for our health. A photo of deionizer. We generally doesn't use a deionizer in our RO plant, but sometimes somewhere we can see the deionizer. After that we process to our third part of our RO plant, which is distribution system. The processed RO water is put into a tank which generally made of steel because it lowers the contamination, and then water are sent to for dialysis in our dialysis unit. So it is recommended that a corner is going to be oval shaped, not like L shape, because L shape can growth bacteria and there is no dead end of a pipeline. So it is a basically recirculation process where water from the storage tank recirculate and again drains in our tank. Ultraviolet light. UV lights are used to kill bacteria. UV lights processed by the mercury vapor lamp which bacteria exposed to light will be killed. Since UV lights kill bacteria, they can produce endotoxins. So people who don't know what are the endotoxins are, this is the dead body of our bacteria and must be followed by either RO plant or endotoxin filter. UV lights are incorporated into the water treatment system as specified by the manufacturer and we not required on all water treatment system. This is a diagram of our ultraviolet ray. Water passes through the pipe, hollow pipe, where a UV ray can destroy our bacteria level. So dead bacteria produce endotoxins. So if we use a ultraviolet light, then we have to use a endotoxin filter. Here is a photo of our UV filter. So in the later part of this video, we are going to know some questions from the RO plant in dialysis unit. So keep watching our videos and wait for part 2.